Unlike many other cosmetics that have a history of hundreds or even thousands of years, nail polish, or lacquer, or enamel, is almost completely an invention of 20th century technology. Nail coverings were not unknown in ancient times. The upper classes of ancient Egypt probably used henna to dye both hair and fingernails, but essentially, its composition, manufacture and handling reflect developments in modern chemical technology. Modern nail polish is sold in liquid form in small bottles and is applied with a tiny brush. Within a few minutes after application, the substance hardens and forms a shiny coating on the fingernail that is both water and chip resistant. Generally, a coating of nail polish may last several days before it begins to chip and fall off. Nail polish can also be removed manually by applying nail polish remover, a substance designed to break down and dissolve the polish. There is no single formula for nail polish. There are, however, a number of ingredient types that are used. These basic components include film-forming agents, resins and plasticizers, solvents, and coloring agents. The exact formulation of a nail polish, apart from being a corporate secret, greatly depends upon choices made by chemists and chemical engineers in the research and development phase of manufacturing. Additionally, as chemicals and other ingredients become accepted or discredited for some uses, adjustments are made. For example, formaldehyde was once frequently used in Polish production, but now it is rarely used. The primary ingredient in nail polish is nitrocellulose, cellulose nitrate, cotton, a flammable and explosive ingredient also used in making dynamite. Nitrocellulose is a liquid mixed with tiny, near-microscopic cotton fibers. In the manufacturing process, the cotton fibers are ground even smaller and do not need to be removed. The nitrocellulose can be purchased in various viscosities to match the desired viscosity of the final product. Nitrocellulose acts as a film-forming agent. For nail polish to work properly, a hard film must form on the exposed surface of the nail, but it cannot form so quickly that it prevents the material underneath from drying. Consider commercial puddings or gelatin products that dry or film on an exposed surface and protect the moist product underneath. By itself or used with other functional ingredients, the nitrocellulose film is brittle and adheres poorly to nails. Manufacturers add synthetic resins and plasticizers, and occasionally similar, natural products to their mixes to improve flexibility, resistance to soap and water, and other qualities. Older recipes sometimes even used nylon for this purpose. Because of the number of desired qualities involved, however, there is no single resin or combination of resins that meets every specification. Among the resins and plasticizers in use today are castor oil, amyl and butyl stearate, and mixes of glycerol, fatty acids, and acetic acids. The colorings and other components of nail polish must be contained within one or more solvents that hold the colorings and other materials until the polish is applied. After application, the solvent must be able to evaporate. In many cases, the solvent also acts as a plasticizer. Butyl stearate and acetate compounds are perhaps the most common. Finally, the polish must have a color. Early polishes used soluble dyes, but today's product contains pigments of one type or another. Choice of pigment and its ability to mix well with the solvent and other ingredients is essential to producing a good quality product. Nail polish is a suspension product, in which particles of color can only be held by the solvent for a relatively short period of time, rarely more than 2 or 3 years. Shaking a bottle of nail polish before use helps to restore settled particles to the suspension. A very old bottle of nail polish may have so much settled pigment that it can never be restored to the solvent. The problem of settling is perhaps the most difficult to be addressed in the manufacturing process. In addition to usual coloring pigments, other color tones can be added depending upon the color, tone, and hue of the desired product. Mica's tiny reflective minerals, also used in lipsticks, are a common additive, as is pearl, or fish scale, essence. Pearl, or guanine, is literally made from small fish scales and skin, suitably cleaned, and mixed with solvents such as castor oil and butyl acetate. The guanine can also be mixed with gold, silver, and bronze tones. Pigment choices are restricted by the Federal Food and Drug Administration, FDA, which maintains lists of pigments considered acceptable and others that are dangerous and cannot be used. Manufacturing plants are inspected regularly, and manufacturers must be able to prove they are using only FDA-approved pigments. Since the FDA lists of acceptable and unacceptable pigments change with new findings and re-examinations of colors, manufacturers occasionally have to reformulate a Polish formula. Early methods of making nail polish used a variety of methods that today look charmingly amateurish. One common technique was to mix clean scraps of movie film and other cellulose with alcohol and castor oil and leave the mixture to soak overnight in a covered container. The mixture was then strained, colored, and perfumed. Though recognizable as nail polish, the product was far from what we have available today. The modern manufacturing process is a very sophisticated operation utilizing highly skilled workers, advanced machinery, and even robotics. Today's consumers expect a nail polish to apply smoothly, evenly, and easily, to set relatively quickly, and to be resistant to chipping and peeling. In addition, the polish should be dermatologically innocuous. Hey guys, thanks for watching this video. If you want to know more videos, subscribe and support our channel.